A cell membrane is made of phospholipid, and within the phospholipid there are proteins. Some of these proteins are channels, which means that substances can pass between the outside and the inside of the cell. The protein channels will only let some substances pass. This is a potassium channel, and this is a sodium channel. What happens with these channels is important for determining the resting potential and then the action potential. The way in which potassium ions and sodium ions move through the channels between the outside and inside of the cell is a combination of the concentration of the ions and the electrical forces acting on the ions. At rest, the cell membrane is more permeable to potassium. Potassium ions are able to leave the cell until an equilibrium is reached between the concentration of potassium ions and the electrical potential across the membrane. At this point, the electrical potential of the membrane is known as the resting membrane potential. To form an action potential, the membrane potential must change. For this to happen, ions must move. Firstly, the sodium channel opens. This allows positive sodium ions to enter the cell because of the concentration gradient and electrical force. Entry of the sodium ions causes the membrane potential to depolarize to a peak. This influx of positive ions creates the electrical signal known as the action potential, which then flows down the axon. When the action potential reaches this peak, the sodium channels begin to close. The change in membrane potential also causes potassium channels to open, allowing potassium ions to leave the cell. This causes repolarization. Finally, both types of channels close, and the membrane potential returns to resting value.